The last bit we're going to do that kind of fits into the realm of naming or drawing isomers and things like that is the classification of haloalkanes and alcohols. And we can designate them as either being primary, which is this 1', secondary 2', and tertiary 3'. And it's quite straightforward really. To classify them as either these, we need to count how many carbon atoms are attached to the carbon atom with the OH group or the halogen attached. So, for example, here in the first one here, we have the carbon with the OHs in red, and it's next to one other carbon. Therefore, it is a primary alcohol. The next carbon along is two carbons attached to the carbon that have the alcohol group, therefore it's secondary. And finally, the last one has 1, 2, 3 carbons attached to the carbon with the OH. That is a tertiary alcohol. Now, this factor of being primary, secondary, tertiary does have an effect on how fast it can react and the sort of reactions it can do, but that's something that really you go into more detail at university, so we're not going to worry much about that, but we need to be able to classify things and explain. And your explanation will be simply, for example, if we got the second one, we say this is secondary because the OH group is attached to a carbon which is attached to two other carbons. Just like that. And the same applies to the haloalkanes. So if we look here, this is the carbon with the Br group, the halogen, and it is attached to just one other carbon directly. Therefore, it is primary. This other one here is attached to two carbons directly. It's secondary. This one here is attached to 1, 2, 3 carbons, therefore it is tertiary. So it's the same deal as the alcohols except for with halogen. So this is a skill that we need to be able to use and be able to identify as you'll see in the 2016 exam.